Okay, so we are back for the final example that I'm going to complete for you. This is another one where we're going to have to multiply both sides of the equation by the least common denominator of all of the rational expressions because this is not a proportion like we saw in example number 3. So let's go ahead and get started in on that. Just like the previous videos, I'm going to rewrite the equation to get started. And there we go. All right, so first thing I'm going to do is I'm just going to look at all the denominators, see if I can factor them any further, um, and then try and determine what the least common denominator is. If we look at the first expression, x minus 3 is factored as far as it can be factored, so I'm just going to leave that alone for now. X squared minus 9 is a difference of squares, so that factors to x plus 3 times x minus 3. And then the last expression that we see, negative 4x over x plus 3, again, x plus 3 is factored as far as it can be factored. So it looks like the lowest common denominator, or the least common denominator in this case, is going to be x plus 3 times x minus 3. All right, so in a scenario like this where this is not a proportion, we're actually going to have to multiply both sides of this equation by the lowest common denominator. So let's go ahead and do that. This is going to get a little messy. But just like in the previous example, um, things start to simplify down and become pretty nice and pretty easy to work with pretty quickly. So that's a good thing. All right, so multiply times the left-hand side and then both of the expressions on the right-hand side of the equation. And I'm going to write that right here. All right, so we've got 6 times x plus 3 times x minus 3 all over x minus 3. That's going to equal 8x squared times x plus 3 times x minus 3. And I'm going to write x squared minus 9 in its factored form, x plus 3 times x minus 3. And then finally we have minus 4x times x plus 3 times x minus 3. And it's going to be all over x plus 3. All right, so this looks like a big mess right now, but it's actually going to simplify down pretty nicely as we work our way through. So let's go ahead and start simplifying. So I'm going to start off with the first rational expression. And to simplify this, I'm looking for common factors shared by the numerator and denominator. So in this case, the numerator and denominator share an x minus 3. So I'm going to divide that out, which is going to leave us with 6 times the quantity x plus 3. Okay, on the right-hand side of the equation, the first expression, grab a different color marker or pen here. So this one, a lot of nice things happen. X plus 3 and x plus 3 are shared by the numerator and denominator. Same thing with x minus 3, so that's going to simplify down really nicely to just 8x squared. And then finally, the last expression, we have negative this mess. It looks like there's a common factor of x plus 3 in the numerator and the denominator, so we're going to get negative 4x times x minus 3. All right, so not too bad. All right, so let's go ahead and continue to simplify this and then try to solve the equation. So I'm going to multiply that 6 through the parentheses, distribute that to each term in that quantity. So it's going to be 6x plus 18. And that's going to equal 8x squared. Now we're going to distribute the negative 4 through the parentheses. So negative 4x squared and plus 12x. So this looks a lot like a couple of examples that we've done already where we have a quadratic. So let's try and solve this quadratic equation. The way that I'm going to do that is start to combine like terms. So I'm going to rewrite 6x plus 18, and we're going to combine terms on the right-hand side. So 8x squared minus 4x squared is just 4x squared plus 12x. All right. So now what I'm going to do is move everything over to the right-hand side of the equation to set this equal to 0. So we'll subtract the 6x from both sides and an 18. So we can 0 out the left-hand side. And actually, I'm going to move that over here. So subtract 6x and then plus an 18. All right. I apologize for the handwriting. My computer is not liking this right now. All right. So this leaves us with 4x squared. 12x minus 6x is positive 6x. And then the positive 18. And that's going to equal all of this over here zeros out. And now we are left to solve this equation. So as usual, I'm going to try to solve this by factoring. If you look, there is a greatest common factor of 2. So I'm just going to divide quickly both sides by 2. And this is going to give us 2x squared plus 3x plus, actually, this should be a up here, plus 9 equals 0. Yes, this 18 up here should be a negative. Sorry about that. Let's fix that real quick. So that's a negative. All right, and that's going to make this a negative 9. Okay, good. So we've got everything set up. All right, so now we're going to factor this. You can do this with the area model if you want to, but again, this is just going to factor as 2x minus 3 times 2x, I'm sorry, times x plus 3. And again, I would suggest using the area model if you don't know how to factor that. So I'm going to set each factor equal to 0. So it looks like we're going to get x equals 3 halves, or x equals, this is a 0, negative 3. All right. So a common theme throughout these videos is that I want you to check your solutions. And if you look through the notes that I've posted to Google Classroom, you'll see that I've checked my solutions in all of these cases and everything's worked out. Well, in this case, x equals 3 halves, that's going to work. When you plug that back in, again, you can go and see that I checked this as you go through my notes on Google Classroom. You'll see that x equals 3 over 2 is a solution to this equation. However, x equals negative 3 is not. So if you remember back when we were solving radical equations, we talked about this idea of extraneous solutions. In this case, x equals negative 3 is an extraneous solution. And let me show you why that's the case. So we go back up to the original equation. And we're going to do 6 over, this is a 6. I don't know why my computer won't allow me to write that. But negative, I'm sorry, was it a 3 or a negative 3? Negative 3. So negative 3 minus 3 equals 8 times negative 3 squared all over negative 3 squared minus 9 minus 4 times negative 3 all over negative 3 plus 3. And again, I'm sorry for the writing, but my computer is not liking this right now. So here's where the problem occurs. If you look at this denominator and this denominator, both of those denominators equal 0. And as you know, division by 0 is undefined. So the moral to the story here is that x equals negative 3 is not a solution to this equation. The only solution is x equals 3 halves. So this is an extraneous solution. So check your answers. Sometimes it might even be easier to check these graphically. So if you go to Desmos and graph the left-hand side and the right-hand sides of the equation, see where they intersect. That's, that can be helpful. Or just plugging them in um, the old-fashioned way and evaluating the left-hand side and the right-hand side and seeing if they're equal. But again, you definitely want to check your answers because in these types or with these types of problems, there's definitely a possibility that you might encounter extraneous solutions. All right, so you're going to go ahead and practice now. If you have any questions or concerns, make sure that you email me or message me through Google Classroom. I hope this video was helpful, and we'll see you soon.